Hello, everybody. Welcome to week 2 of the advanced simulation and game design. Got a few things to go over today. I guess first off, a reminder on Wednesday, our class will be a little shorter than normal. We will only go up to about the time we normally take a break. And then the rest of the time afterwards will be for working on things because there's a project due this week. So the extra hour to work on it probably be nice. And then, yeah, right after class, I have to throw my suitcase in the school's vehicle and head towards French Lick. Which also along those lines, I might not be as quick as normal at responding to emails, but I will still be checking them regularly for, Wednesday, Thursday, and Friday. I'll be at this big event. So might be a little bit delayed getting back to emails, but I'll get to them as quickly as I can. So what we got? Started looking at tile map stuff the other day. This is the design class, so drawing those up, looking at some of those. Along with tile maps, there was when I was looking at the quizzes that are, or not quizzes, knowledge checks that have already been submitted. They're very low stakes things, just reinforcing the reading assignments. I noticed one question that was seemed to be missed by several people. It was a true false thing, said something about tile maps can only be used in 2D games, and several people had marked false. There's another tool very similar called grid map for 3D. It just has the tile maps only lay flat, so tile maps are just for 2D, and then the 3D one, there's a tool called grid map. We'll look at that at least briefly. They're very, very similar, like a lot of things in the Godot game engine. The tool is set up so the 2D and 3D are handled essentially the same. They just add one more dimension to work with. Okay, just checking the chat there. Also, the first graphical assignment is due this week, sprite sheet animation. So I want to kind of go through some stuff on that, because coming into this class, some people might not have a lot of previous experience with graphics. And a little bit more to talk about with vectors this week. The reading assignments covers vectors, and then the tools for loading into the sprite sheet once you have that written. And with the sprite sheet, you're going to want to take your time, do multiple drafts, try to get something really nice. Because when we get to the module 7 discussion board talking about game assets, this is one skill set. We don't have to wait until there's like a finished game to start monetizing it. We can sell the assets to other game developers as well. So we're gonna do that in the module 7 discussion board. All the steps up to ready to hit the publish button. So it's up to you whether you actually sell it or not. And in the instructions, the recommendation is to use this 2D sprite sheet to put out there. Use that for example. So what you want to go for here is something that you would be proud to put out there and try to sell for a couple dollars or something like that. Yeah, we talked a little bit about vectors the other day. We don't need to dive real deep into linear algebra, but we do need the computer handles all the calculation for us. We just need a bit of intuition of what those vectors are doing when we start putting them in our code and working with them. And then the Git plugin that I messed up on Wednesday's class. If you remember, I tried to activate the plugin before installing Git on this computer, because apparently I forgot to install Git on this computer when I did a factory reset right before class. It's fixable, but not for that small example it was on. It wouldn't be worth the effort. It would take longer than it took to put that example together. Because what it is it created all of the configuration files with the wrong wrong usernames and a couple settings that were off. Would be also just have to go to the configuration files and retype stuff. But solid work for us for that small example. That was just introducing rigid bodies because week one is you pretty much just preview mode. Everything we saw last week, we're going to see again. That's getting situated in the class, making sure our schedules are set up right, and easing into the class. So it was a small example. With it, the easiest way to handle it is actually in the terminal. So I guess we can start there and kind of look at both of them. I'll share my screen, and then we'll get to the things that have notes on the board, stuff like that. So I'm going to start a new project in Godot. Actually, first I'm going to go in and probably delete, and you need to delete this one and this one. Don't need those around. That's the ones that got messed up last week. So I'm start up Godot and create a new project. Remove all those missing ones. So just like always, can you see the board okay? So one thing that can be helpful, I can turn the projector on. Will that help? Yeah, let me just say it. It can also be helpful on these machines to log into one of the extra machines here and just pop on the Zoom call from there. Then it's like a second screen. Or is it that one closer to you? Okay. Yeah, there's a somewhat limited. Hopefully, it's easier to see on the board there. Okay, well, so there's no glare on it. So we'll create a new project. Yeah, I'll just go with that name because this one we were just creating the project to look at the Git plugin. Compatibility mode, because that gives us the most outputs, desktop, mobile, and web platforms. And yeah, near the end when we get to exporting and stuff, the exporting assignment is going to be like an HTML export, one for websites. But that's still a few weeks away. So I'm just going to hit create a new project. And as always, it's as it starts up, it's writing a bunch of text files in the background, which when games get really large, some of that automatically generated stuff can just be overhead. That's what that other down thing that we download with is, the console version. When we download that, if we want to just type those text files ourselves and have the bare minimum for our games, we don't have any overhead or anything. The save RAM, when it gets really large, we can do that. Or generate a bunch of files and then go in and edit the stuff parts you don't need out of them. That might be even easier. So here's all of this stuff, and let's go through the terminal way. Because I also have a video I can share with you all. I included it in that online channel I'm making, but for the statewide online courses, I was asked to make a short reference to Git with like the 7 or 8 commands, the bare minimum that we need to do the version control locally and connect to GitHub. So I made that video over the weekend and send it out to you all soon. I use PowerShell, so I'm going to start PowerShell. If you're on a Windows machine, you can go to the address of File Explorer, and that will start it right there. If you're on a Mac, you hold down the Option key, or you go to the place you want in Finder, and you hold down the Option key. Breadcrumbs will show up along the bottom of Finder, and If you click on those breadcrumbs, one of the options in the menu will be to open terminal here. Or you can just open it anywhere and navigate to the directory. As long as you get to the game project in your terminal somehow. He said, okay. Um, so first thing we need to do is initialize the project for version control. Yeah, Jenna put in there, put it in the chat that Git bash works a little bit better. And yeah, it does, because Git was entirely created in the bash terminal. So it runs a little bit smoother, but I'm just gonna go with this one. So all of our commands are just Git, which is not an acronym. That's Linus Torvalds always names stuff after himself, and that's British English for an unpleasant gentleman. We have in American English, we kept the term for women, but dropped the one for men. Starts with a B. I'm sure everybody's heard that word before. So that's what that actually means or stands for. Yeah, there's lots of ways, as long as you have a place to type. First thing we need to do is initialize the folder. So command init. So git initialize, and then we could type in names of folders here. If you haven't seen it before, the dot operator, that refers to the folder you're in and all of the subdirectories. So we just say git init dot, that's going to initialize this project and all the subdirectories in it and everything. It's really useful when we're doing things this way. So initialize an empty Git repository. We come over to File Explorer, or I'll do it on the screen here. You see it created a new folder. It might be hidden on your view. This .git folder. If we go in there, there's a bunch of configuration files, information about the current and previous version. So what it does is it stores, whenever we make a commit, it will take a snapshot and track the entire project. And then every time we commit more changes, it goes through and then only keeps track of the things that have changed. So that there's very little overhead. We don't have the entire version every time. We have the original version and then a list of all the changes that came afterwards. So now we need to, right now it's just been initialized. We haven't committed to anything, right? All that's been done so far is created that blank project. So to stage our files, usually use terminology like in theater, putting things on stage. Staging is like when the actors take their place but haven't raised the curtains and turned the lights on yet. We just have everything there, and then the commit is when the curtain goes up, everything's finalized at that point. So it's just the command add, and I always like to use the dot. If you want certain files, you can type them out, but again, the dot means this folder and every subdirectory in it. So now we have a bunch of files ready to be considered part of the row change. So I'm saying git commit, and then -m for message, and we give it a short, meaningful name, something to help us keep track of which version this was. I'll just call it an initial commit. Sounds like a good name, and it does need to be in quote marks, a string. If there's no spaces, you could leave the quote marks off, but probably better just to always put quote marks there. Then we can have more than one word and don't have to have things named like variables. What's that?
The gray one, I can't see it.
-m. Yeah, so message is what it stands for. I always remember what it stands for because arbitrary letters kind of run together after a while. So one thing about Git is you'll notice Git has excellent error messages. The error messages are usually spot on, tell you exactly what you need to do to fix it. Like it'll say this would error and some of the computer error stuff like we're used to seeing from programming, and then it'll have suggestions on how to fix it. So here, I haven't signed in, I haven't coded who I am yet, basically. So, and they tell us, okay, you need to run these 2 lines with your email address and your name. So git config -- global user.email and this is the email I use. My personal email instead of the school email. It's what I always use on GitHub. You want to use the same email that's on your GitHub account because we're going to connect it to GitHub. So run that command and then run the other command, which obviously they give us what it is, so we can just copy and paste it. And the only thing I actually have to change here is what my name is.
So the first half is this half is so yes.
Oh yeah, we get
I did that also before.
we're using it more and more. The version control class has started running. There's a full group credit hour class on Git that does a very deep dive. There's a lot of stuff to it. But it's getting used in all the classes. That's why over the weekend I made a video that does this right here. I'll send it out, but it's pretty much doing the same thing that we're getting ready to walk through right now. So it's also on our Zoom cloud recordings thing on Ivy Learning. So I'm just gonna hit up a couple times to get back to that initial commit command because that never ran. Okay, so now shows what all's happened. So we created 6 files have been changed, 67 lines between them from that stuff. So an important one that you're going to want to is the log. So this tells us all the changes. All of it, everything on Git is going to start with Git, and then log tells us the changes. So there's a lot out there. This right here is why you need the that useful human readable message, because when we start working with stuff, it's that number right there, and we're not going to keep track of it. But it is specifically set up so that there's a short version of it. We can use an abbreviated version of that number. There's a lot of information there, and it's also customizable. So when you do log, you do -- one line, you get a more concise version. And we just see like the 6 or 7 digit version. And then we can copy and paste that when we need to do other stuff.
So by default, it's verbose.
Mm-hmm. Yes. And yeah, everything's customizable, even the colors of the stuff. So we're not getting that far into it. So just remember git log, and you probably want the -- one line. It makes it a lot easier to keep track of. Let's make a change since here in a moment we're going to push this up to GitHub. We probably want a README file. So I use the Sublime text editor. You haven't used that one before. It's one that I think it costs around $100 right now, but it's a lifetime license, forever license. Paying for software is rough when you're a student. You can also use it forever for free. It just says unregistered version. When you're a student, paying for software is very, very rough. But after you graduate and you're out there making really good software developer money, and the IRS wants a really, really big chunk of it, any software that you buy that you pay for becomes a business expense. So it comes off of those huge tax expenses every year when you're making 140 grand a year. The IRS wants a really, really big chunk out of it. So at that point, paying for software is a little bit nice. Yeah. I think most people are probably using code. Internally, the reason I like to write, I use the Sublime one. The Sublime text editor will make use of GPU, or in case of my laptop here, that has the Intel integrated graphics that act like GPU. And then when you're doing telemetry and stuff, the programming part is running on the GPU and not taking up any RAM or anything. So you get better measurements of RAM usage and CPU usage from the program you're creating. That's why I use Sublime. But they pretty much all have the same functionality, same stuff, as long as you have a place to type. I'm going to have that create readme.md. If you use VS Code, the word is just code. It should have installed automatically. Might need to set an environment variable if not, but code automatically starts VS Code, and if you put in the name of a file afterwards, or space delimit several names, it'll create those files. Oh, look. It apparently didn't, let's go over how to do that. Might as well. So it didn't recognize in my text editor. I think I said something last week. I do factory resets every term. And this time I set up this computer while I was sitting in a mechanic's garage waiting on putting new shocks on my truck. And yeah, when they said it was finished, I closed the computer, and I think I wasn't quite finished setting things up. So if it doesn't recognize the text editor you like to use, that's an environment variable. So if you're on a Mac or a Linux system, it's going to be your path variable. On Windows, it's always a path variable, but $path, and then just concatenate the location of that text editor. On Windows, we have this nice little GUI for messing with it. Under the advanced system properties and the advanced tab, I just search for environment variables. And it should open this box if you click on the advanced tab, if you're not there, and you see a button for environment variables. And this is all the software that your computer knows about. Up at the top is the user, down at the bottom is for anybody that logs on. Notice both of them have this path variable. It's also called path on a Mac and a Linux. Theirs is a little bit easier to do, is just concatenate it onto the end of the long string and on Mac or Linux. But what this is it's pointing at all the software the computer knows. So your programming languages, anytime you install a programming language on a computer, it's only going to know about it if you add it to this path variable. Then we just need the location of it. You can see it's just a long list of locations. Well, some of them have variables there, so it doesn't quite look like locations. The one right above it for Git, right? That's just pointing to where Git's at. So click there, browse to a new spot. I just happen to know where this is. Program files, Sublime text. Sublime merge is also the graphical Git software that I use. So I click on this, point to that folder. I'll go in here.
So can merge also be used for free?
Mm-hmm. Yeah, their stuff can always be used for free. They just charge so that they just have the charge option so that you can put that on your taxes every year. Because people who would be using it have rather large tax bills. So here it is right here. Here's the application. SUB, the actual application, subl.exe. So we're going to point at that. So really, we just need to copy the address to it. And then in that, I guess I was almost there. copy that and then add in the executable. So in my case, sublime.exe, your on VS code, um, brackets. I've heard a lot of people are starting to use brackets again. Whichever one you use, I'll go ahead and do the smart sublime merge. Might as well look at that while we're looking at good stuff, right? And just like the text editor can be used for free forever, but it just says unregistered version at the top. All the functionality is there. So this one's smurge.exe. Just add it to that list. Which is an important thing to go over in SDEV class anyway, because when you get to the point you're making installers and stuff, you want to make sure to do that. Make sure your installer does that for users so that your software is going to work on their system.
Just a quick note too, make sure you edit the system environment variable. If you edit the user one, it tends to not work unless you're doing it under the correct user. And typically you have to install programs as admin. So unless your user is admin, it won't work.
Yes. Thank you, Clayton. That is, yeah. Yeah. Oh, it's always best to do it on the whole system. So I'm going to run that command. Oh, after restart the terminal. We've made changes to the environment variables, so we have to restart the terminal in order for those to work. So I'll go to where the game's at, and I just hit Alt-D to get to the address bar. Same thing we've always used for address bars on Windows. And on Linux, hold down Option, and then click on the breadcrumbs that show up at the bottom of Finder, and you get to open the terminal. But I keep saying address bar. Technically, this right here is one line entry to PowerShell, is how Windows is currently set up. So you could actually type all of the git commands right there. I do that sometimes. I'll just go and like right here, type get rid of the address stuff and do like git commit -m and then type the message right there and it'll work if you're on a Windows machine. I'll zoom back in. So now if I have the Sublime text editor, created readme.md, that's for Mark. Did I do something wrong? Okay, I must have did something wrong on that. Let me try that again. Edit system environment variables. You know what? I bet I don't need exe at the end of those. Go to add. I'm going to stop at the folder name and see if that fixed it. You can also just type restart in terminal, but I find it's easier just to close it, reopen it. Okay, now it recognizes it. It's enough just to point at the folder it's in, and then it'll look through all the folders. All right, so let me try this again. Create that README file. At this point, it would have been a whole lot easier just to open the text editor and hit the new button. But so the MD is markdown language. At least some of y'all have probably seen HTML at the HTML class. The markup language is where we add tags at the beginning and end. So it's like more stuff in a markup language. In a markdown language, we use special characters to do that stuff. So like 2 dashes is a level 2 header or hashtags. 1 hashtag would be a level 1 header. the equivalent of typing H1 in HTML. 2 hashtags is a level 2 header, and I think you can see we still have 6 levels of header.
So with these readmes, does that mean you can add an image onto it then?
Yeah. Also, in Markdown language also accepts HTML. So if you're like going to put it on GitHub, you could. Sometimes it's easier just to use the add in the HTML tags, but it uses special characters. Then for underlining, we can do 3 underscores or 3 dashes. They give us different levels of underlining. Yeah, that's probably enough, but just the general idea there, y'all can do a Google search and pull up a list of what the special characters are. Mostly you're probably going to want headers and lines separating things though. So a quick example stuff I'm using Git and game there. Let's go ahead and save that. All right, so made a change. We'll have that README ready to add to it. So things have changed and since our last version, so we want to add those files there. So we initialize it once, and then this is the part we do over and over again. Every time, once we've made certain changes, we're satisfied with the changes that have been made, we'll stage those changes. Okay, it has different line in. Looks like my text editor is set for just the line feed instead of the carriage return line feed. To kind of set it different. Where the name comes from is typewriter days, that carriage that moved back and forth on the typewriter. A line feed would only turn that to the next level. And if it just turned to the next level, but we didn't move the carriage, we'd start typing at a different spot on the page than over at the left margin like we normally do. In computers, that's usually not a problem because if you do a line feed, there's nothing on the next line, so it can only start at the beginning, but not always. For example, what is that Microsoft Note thing? OneNote. The next line isn't empty, so it starts way. If you just do a line feed, it starts way over to the right, at the spot your cursor was already at. So that's why carriage return line feeds are usually better. But Git is going to automatically retype all of that. You see the messages they give us are really nice. So now that we've added those changes, we'll commit to those changes, add README. One line or one file with 3 lines in it. Git log. So pull up the history with that one line parameter in. You can see now we're on the main branch, currently looking at the 2nd version of the software. It has the README in it. So there's that README file. But we can, one that's going to be really useful is our checkout command. So if we do git checkout, and then we can check out different versions, whether earlier commits or different branches. So I'll come back to the initial commit and paste that ID in, and it can be the abbreviated one from when you do add the one line parameter. So I'll check out that earlier commit. We get all of this. So we're looking at an earlier version, and we can either type, when we're done looking at this version, we can type switch -C and start a new branch from this point. So then we have 2 different versions of the software moving along. That's really what Git's for. It's not just a storage thing. Or if we do git switch and dash, it's going to go up, it's going to cancel this. It's going to move us back to that latest version, latest commit we were looking at. I'm going to go ahead and do a new branch. Git switch -C and then some sort of name for it. And this one does have that. Branch names do have to follow our normal variable naming conventions. So no spaces, can't start with a number or special character. Can only use certain special characters, all the normal variable naming conventions. So I'll call this no readme. I have a no readme branch. And if we check the log, oh yeah, I forgot to look over here. Over here, this started whenever we went to the checkout. Notice that that readme file is gone because we're looking at the earlier version. That's very important in game development projects where there might be a lot of changes, or could it end up with a big bug somewhere and you're not sure what to do, having trouble tracking it down. You can go back to the last version that worked and kind of walk through those steps again. Recreate it without the bug. Yeah, that'll work. I think there's just 2 branches. Couple useful ones. If we type get branch, it'll list out all the branches we have, say which one it is, and we can check out different. Also use checkout to see the branches too. So if we say get checkout main, or you can see we switch back to the main branch. There's several ways to create a new branch. The easiest way, if you type get branch, like you're going to look at them, but then add a name of a non-existing branch, that'll add one. I'll say other branch. Don't really need to do anything with that, except show you it created it, but notice it didn't switches over to that other branch. We have to come back and work on that. So that's the big thing. So add will stage all your files. And then usually easiest just use the dot operator. Once we stage the changes, commit to the changes with some meaningful message so you can keep track of it, because the IDs are a long string of hexadecimal numbers. Now after you've done so many changes, check out, and then either a commit name or commit ID or a branch name, and then you'll be looking at the other version entirely. So like when you go back to File Explorer or back to your Godot engine editor, you'll see the earlier version. Yes.
So you might make a new branch if you're wanting to do like version 1.0, 1.1, 1.2, and so on.
Mm-hmm. Those would be very useful names. Usually version that sounds like the release numbering, but if it makes sense and helps you keep track of it, that would work. The reason we're looking at this is because the homework assignments have to be turned into Git, right? So we want to connect, or have to be turned into GitHub. So we want to connect this to our GitHub repository on GitHub, which is just a website that runs all the Git software on the server somewhere. There are lots and lots of them. Some people like other. Some people prefer different ones. GitHub is owned by Microsoft. I think that's the main reason some people prefer different ones. It's just to not be using Microsoft product. I'll come in here and I'll create a new repository. And we don't want to have any conflicts. So we want a completely blank one. That way there's nothing that will conflict with all the files we have on our local repository. I'm going to call it terminal_example. It's what I'll be deleting soon. just make sure the name's available. And then leave the description blank. Yeah, leave everything else blank, public. Don't need to add a readme, you already have that on at least 2 of the branches. Don't need a license at this point. But when you create a blank repository, it shows you the instructions for connecting to a remote one. I said how to visualize it, make the commits, set up our branches, and then it gives the instruction on how to connect to it right here. So copy and paste line. So get remote, add origin. So we just need to connect, create a remote connection. And they give us the line so we can copy and paste it. So when you create a blank repository, just copy and paste that line or type it all in if you want. So now should be connected to that repository. So to put our stuff there, we use the word push to the repository and pull from the repository. So if we have changes on the remote repository that aren't on our local machine, we say get pull, and then what branch do we want to pull from? So we set up we added an origin. So we want to push to the origin on our main branch. And to get things from there is just change push to pull. That's better than I was expecting it to. Oh, so I'm not signed in. Sign in the browser. Okay, there we go. I was already signed in on the browser, just hadn't done it from the terminal yet. So now it should push all that stuff up. Yeah, push it up there. If we reload it, see there's our files. Automatically detected the README in there. You can see what that hashtag for the header and then the underscore makes the thick line. If you use 3 dashes instead of underscores, it gives a thin gray line. Only gave us 1 branch though. We do have to push each branch up independently, which is probably a very good thing because normally we would make changes on a side branch, not on the main branch. And we don't want to push everything up at once and mess up a branch we're not working on. So we get the other ones up here. I'll just list them all out. We have those other 2 branches. So get, push, origin, and then the no readme branch. We'll add all of that. Get, push, origin, other branch. Push all that up there. So we reload. Now we've got all 3 branches up here. All the changes and stuff, probably no surprises. So you can see all the branches are there, where what matches the origin, what doesn't. We get a lot more information. Git log. 1 line. There's not much to see here. I'm trying to pull something up, but it's nothing interesting to see. It'll also draw the connections between the branches. Oh, actually, I have to go back to the main, don't I? Git check out main. Okay, yeah. The along with that text editor, Sublime also has this remote one, open repository, or, not remote, this, GUI for working with the Git stuff. What?
It doesn't have the doesn't have the repository folders, so it just had the folder that the application to.
Oh, that's why. There we go. So yeah, those lines and the branch showing branches and stuff can be whenever they start to get complicated and see different lines to track through, that can be useful. And get all the different information, see all the changes and stuff.
Git does also have a Git GUI as well.
Yes.
But
It has that. It's built into most IDEs. So like here in Sublime, if zoom buttons would get out of my way. There we go. Notice that right now it's just showing text stuff, but if I open that README, no, down at the bottom there's this Git option. I think I click on that, and then that opens that, which has, it's kind of a nice one for working with. It's not the best one. The best one is Git Kraken. It's not free though. You can use it for free for 30 days. So Kraken, like the mythical beast, that's probably the best GUI for working with Git. That's the main parts we'll need. That all that makes sense. How to push, how to commit to all our changes and then get it up there. That's probably a lot easier. Now that Git exists on here, I could do a I'll make a new project, so I'm gonna close this one because I was just for that example. And go through that thing that I messed up on Wednesday. Because the plugin's useful because then our button is right there. So whenever we in our coder, it'll kind of like that button I just clicked in on the Sublime text editor.
it'll commit the changes, but it won't push them, so you have to do that yourself.
Yeah. So it wants the SSH connection, which takes a couple extra steps to set up. When I made a video, it was pushing 45 minutes on the video. So I just scrapped that and went to just type in the remote origin connection and the get add origin, like we just saw, and then get push origin main or whatever branch name. And then that made it like a 5-minute video instead of 45 minutes. So there's no difficult steps in there. There's just a bunch of them. So now that we have this, if I go to version control, there's a button for it, but we have to grab it from the asset store first. So we come over to the asset library and search for Git. It's this one here, the red version of Godot's logo with the Git icon laid on top of it. Godot Git plugin. And that does go by project, so you have to download and install it every time in the project. You add a bunch of files to our project. And now we go to project and version control. We can open this up and we'll say connect to VCS. Just this little switch here. Then that opens up a new tab over here by the inspector panel. So then apply. We're going to project settings now. Notice that whenever we did that, it initialized it as a Git repository. So we have all of that. And right here, next to the inspector panel is a tab called commit, where we can handle all our changes. So this is the part that I messed up the other day. So right now we have unstaged changes. We need to add those, so click the little down arrow to move them to the next section. So now they're staged, that's like the ad. Basically, the software just ran the ad. Also with those terminal commands, since this is a software development class, it is really, really nice to have version control work into your software. People find that very, very useful. You can change terminology if it's something that people might not know yet, and just have like some of the key version control features worked in there so they can get back and recover earlier versions. The up arrow unstages it if you want to do that. Give it some sort of message. I'll just call it initial commit. And commit those changes, and then down here we have the list of all the commits. So you click on it, you can see everything that was edited from it. And yeah, so there's a lot of those generated files right now are all changes. And then if you know how to do the SSH connection, right, that's what project said. Whoops. When you first go into the version control option here, where it's asking for yeah, you'll connect to the remote origin the same way, and then you need your username and password, and then you have to have a public and private key along with a secondary this says passphrase, but I believe GitHub requires you to use tokens. So it's a whole lot of extra steps to connect to SSH versus just a couple of lines. Because then once we're done with that, then the easiest thing to do after all the changes have been made is just go over to the terminal and run those last two lines. Remote add origin, and we just saw how to do that, so I'm not going to go through the steps of setting up. Just make sure you set up a blank repository, and then you do git push origin branch name, and probably keep the main branch on GitHub, and then work on a different branch so you can push it up to GitHub, and then use the web interface to create a pull request and merge the branches together once you're satisfied with all the changes.
Branches, I guess, would be, so you have one branch that says version 1.0, and then the main branch is whatever the most recent version.
Yes.
Okay.
Yes. So yeah, the most up-to-date version. And the standard release anymore is CI/CD pipelines, continuous integration, continuous deployment. So instead of trying to push out updates to users and stuff, the installers don't actually install the software anymore. They'll install something that just checks the latest version on GitHub or some other repository. And it caches that, stores that in a cache. So if there haven't been any changes, it opens them up, the one stored there. And then if the repository has changed, usually the main branch has changed, then it's going to pull down the newest version every time. That way we don't have to worry about users not doing updates or other things like that.
Well,
You'll see that in another class.
depending on the game, you just might want to use the version too.
Oh yeah, that's true. So you can give them that option. That's just standard in software development, and yeah, like you would set up if you're releasing games, you'd set up your Steam account to do a pipeline so that every time there's a change on the main branch on the repository, it automatically pushes that latest version out to Steam. So then the next time somebody starts the game and plays it, they're playing a version with bugs fixed. But we might look at that at some point later in the semester because it's pretty much automated on GitHub. They generate files and we go in and change 5 or 6 lines in this 85 line file that it generated. So really, really easy to set them up. So
And I guess let's try usually main version dot subversion dot in the,
Oh, with CI/CD pipelines, there's no longer version numbers. Because version numbers, when we had different ones, we had to keep track of where the bugs were and where they weren't. So there's just the current version.
but if it's not numbered, how do you keep track of?
Maybe just a number and the name. It wouldn't be a full-on release like the old ones. Things are it's set up differently. We'll talk about that later in the semester. Because I can see from your face, you clearly have some questions about it. But we've got other stuff to talk about today. Actively doing stuff, making our games. Any questions about Get There? Quite a bit. And then this is being recorded, so this will be available in Ivy Learn. On the Zoom page, cloud recordings, can get right to it and watch that at double speed. For those who haven't had me before, I can be a bit scatterbrained at times and bounce around a little. So at the beginning of the semester or beginning of a course, I would try to go kind of slow. The lectures will get faster as we move on. I've learned that it's helpful if I start out kind of slow so that as I bounce around, you won't, you get used to how I bounce around. And then when we go at a faster speed, you're a little bit more used to it. So we talked about vectors the other day. Vector, that's the reading assignment this week, and the questions and the knowledge check are based right off the reading assignment. I wrote all the quizzes I went to ChatGPT and said, here's a reading assignment, can you write some great quiz questions based off this, 20 multiple choice, 6 true false, and then threw out the bad ones, because it wrote some really good questions, but it wrote some really, really bad questions too. The worst was in module 3. There might only be the 15 questions in module 3 because that's where we're reading about physics. And instead of going with the reading assignment, the AI took it on itself to ask other physics questions. And they got really, really complicated too. It got to some fairly high level physics. But it's, I think I got all those out of there, and the questions that remain are all related to that. This week, though, there is a little bit of math stuff. The vectors, it's a collection of numbers. That's the easiest way to say it. Numbers that go together. Color is a good example to get away from dimensions for a moment. I'll do a four-dimensional vector because we might want some transparency in there as well. That's either a 3 or 4-dimensional vector. In Godot, we have an object called color, which is just a child of vector with no changes to it. But in some of our other major game engines, when we go work with color in our code, we have to declare that as a vector type object. So color is made up of 3 values between 0 and 255. So maybe 187 red, green, blue, and then alpha values, or A, which is our opaqueness. So 1.0, 100% is fully opaque, and 0.0 is fully transparent. 187, 176, 42, and 0.75. If you have that fourth one, it's just a floating point number somewhere between 0 and 1. Best to think of it as a percent. So like 75% opaque, just a little transparent. This would be a pale yellow, right? And in order, we can't take in the individual number. It's like 187 red is not pale yellow. So the individual number by itself is not enough to describe the color we want. Yes,
Each one goes from what, 0 to
255. So it's each one gets 1 bit. So you may have seen the hex coding numbers and HDN, you had SDEV 153 website class. So that's the standard. So it's actually 1 bit, and we're actually turning on and off the pixels. And usually, if we're working with binary, we do it 4 bits at a time. So hexadecimal. But yeah, a number 0 to 55, what we can fit in one bit, and then a floating point number if we want transparency. But we need all of them. That's the thing. So one definition of a vector is its values that cannot be expressed by a single quantity. And each one of those quantities is called dimension, which would go down a big rabbit hole. Y'all probably think of spatial dimensions, right? We've already just started using that on day 1 in here. 2-dimensional, 3-dimensional games, talking about spatial ones. Even though time's definitely a factor in the game, so that should be 3 and 4-dimensional games. Dimensions, funny thing in mathematics. Dimensions, the definition that refers to itself. When you get to the formal definition, the equivalent thing in spoken language would be a word. How do you define word? You have to use words to define it, right? So it's that starting point that has to refer to itself. Dimension is basically, so think of n-dimensional as n number of dimensions is the number of parameters we need to describe something. So for a color that has transparency, we need 4. For our 2D games, we're mostly going to be thinking about magnitude and direction. Euclidean, from Euclidean geometry, is the technical name for it. The Euclidean vectors, which is, I'll just put direction. Directional. So, maybe I'll write it like normal. Magnitude and direction. We need 2 numbers to make things up. So for like our magnitude, where we go 35 miles, and our direction be 27 degrees north of east. I'll give it like bearings. Get in a plane, go 35 miles at 27 degrees north of east. We know exactly where we'd end up at that point. When we go to code in Godot, they use the word length for the coding, so we don't have to type magnitude over and over and over again, because that's kind of what it is. So think of it as the length. And those are kind of what we talked about the other day, because we needed them in the lecture. Best way to think about it is on our coordinate plane, 3, 4, 5, the 3, 4, 5 triangle. We go 3 units over, 4 units up, we have that point. But another way we could get there is just think about the line that or the arrow that starts at the origin and points to that. So the magnitude is the length of that arrow. So in this case, 5, just from the 3, 4, 5 triangle. And the direction is what's happens to be an irrational number on that particular triangle. But the angle that we're going up, I'll just write a Greek letter with degrees on it. Whatever angle we're going up, and then the length of it. And we can solve that by just thinking about the Pythagorean theorem. We learned that way back in elementary school. And that does apply to any number of dimensions. So when we have 3 dimensions and our arrow starts here and then points off like it's coming out of the board, we just add a third thing to the summation in the Pythagorean theorem, which was cited as common knowledge like 1800 years before Pythagoras lived. In cuneiform tablet, they referred to it as everyone knows. So something people have known since like some of the earliest writing. We learned in elementary school, a squared plus b squared equals c squared, but this has two answers for c, and computers can't do things that have two answers, so we probably want to think of it this way. A squared plus b squared equals the square root of a squared plus b squared equals c. And then our computer doesn't crash when we go to code it. And for 3 dimensions, it should be a squared plus b squared plus c squared, or x squared plus y squared plus z squared. Might make more sense for the variables there. But that's the basic idea. Think about that arrow in space, because we can move that anywhere. The 0.34 is fixed, but if I come over here, and that draw the same thing, that's supposed to be similar, that's still the same vector. We're still going off of that same direction, 3 units over, 4 units up. And we saw on Wednesday working with rigid bodies. That's one we want to work with, rigid bodies and kinematic bodies, because those have all of the laws of physics that we know are already coded in, and they are standard across all of our game engines because they come pre-coded with the laws of physics from the real world. So they're standard across any game engine we sit down at, and it'll feel a lot more accurate. Right? We think applying Newtonian forces. So we change the acceleration, just like when we're driving our car. We control everything by an acceleration. Yeah, Newton's 3 laws. An object in motion stays in motion unless acted on by an outside force, or an object at rest stays at rest unless something comes along and starts it moving. Second law is an equation. Force is mass times acceleration. So we control our acceleration. We control acceleration of the car to speed up, slow down, where we have the accelerator pedal or the brake for the negative acceleration. Because the negative vector just goes in the opposite direction. Right? If we went -3 units down, negative 3 units over and -4 units down, that's just pointing in the opposite direction. So a negative vector just turns us around. So that's what our accelerator pedal and brake pedal do. Steering wheel feels like we're doing something different, but when we turn it, it starts the car rotating, and then we get a rotational force. So it's actually something is pushing from the outside, right? You feel it. You probably felt it before. Right? If you turn a car sharply to the left, everybody in the car gets thrown to the right. So it's not the wheel pointing direction that turns us, it's that. So actually from Newton's 3rd law, every force has an equal and opposite force. The rotational force pushes to the right. Turn your car sharply to the left, we get pushed to the right, but the car goes to the left. Because what we experience is that we experience the equal and opposite. Like standing on the ground here, my body is pushing down on the ground. Gravity's pulling it, accelerating it downward. But there's an equal and opposite force pushing back up. So what I actually feel is the ground pushing back on my feet. The way our tires turn in the car pushes backwards, and then the road then pushes forward on the car. So that sharp turn thing, when the force that we feel inside moves us, kind of throws us to the right, that's the equal and opposite of the actual force pushing on the car. So that's called a normal force. The word normal is going to show up a lot. Normal is, and it's really, really high level mathematics before you get to the point that you can understand why why they're all the same thing, because they will not seem like the normal. There's at least three different version things that are going to seem like different versions of using the word normal in this class. We'll have the verb version normalizing a vector. So to normalize a vector is we keep the direction but change the length to 1. Keep direction, but change length to 1 unit long. So then all we have is the direction that we're pointing. That one shows up a lot when we're coding our games. We want to normalize our vector so that all we have is the direction that we should be going in, and then multiply that by the speed that we should be going in. Which in Godot is, now that I've wrote the word up here, the function to do that is normalized. Just make it past tense, and then it doesn't take any parameters. So whatever vector we have, we want to normalize it. Because we can also add vectors. I'm going to erase this and maybe do a green one. Can everybody see the colors okay? I never know if I should ask that or not. But, I guess technically that's could be a HIPAA thing. Right? Color blindness is a thing, but I don't want to be up here writing notes in a color somebody can't see. Is there any markers I need to throw away? I've heard blue is the worst. People that have the color blindness for blue say it might as well be a white marker on a whiteboard. I'm not hearing anything. Okay. Color coding can help with the notes, but I don't want to write into colors people can't see. For 7, I'll do another 4-2. That way the picture doesn't kind of get off too far. So we can add vectors. When we add them together, we add all the X components and then the Y components, because they are still separate quantities. It's just we need all of those quantities to describe this. And what you could think about, the intuition we kind of want to develop, the computer's going to do all the calculation for us, right? The computer's going to do that adding. But as far as our intuitions we want to work on for developing games, think about a force. If we're moving along in this direction and another force comes in that goes 4 units over, 2 units up, that's going to look something like that, right? And it's going to apply on top of that movement we already had. So it's going up a little bit more, and then in the end, what we effectively have is this new arrow of movement. So that's what's happening when we're already moving and we apply a new force. They're going to add together to give us a new vector, and the computer's going to handle that calculation. But when we're debugging it, we want to make sure we have that. We consider what the summation of the vectors. They can be scaled. So we take like a single value 2 times the 3, 4 vector. We just make everything twice as long. 2 times 3 is 6, 2 times 4 is 8. That one's still going to have the same direction. It's just going twice as far out. When we're coding, what we normally do is we get our vector set up, right? Maybe we we were moving at this from previous things that happened in the game. An opponent comes running at us and hits us really hard, charges at us, hits us. It's going to knock us in a different direction, but we still have some of that forward movement. So we end up with this overall movement. But then we do the dot normalize function so that we have our direction, but a length of 1, and then we'll multiply that by the speed we want to go at. Because if we've been accelerating for a few frames, we're probably up near maximum speed. So we don't want our character going faster all of a sudden, because we're already moving as fast as the character can go, or as fast as we expect player reactions to be able to handle it. So we need to back it off and get just the direction, and then multiply it out to whatever the speed at that point should be. That's mostly what we're going to do with vectors. There's some reading things. So I guess there's just 2 that we're going to use most often. The third normal is only going to show up once. So there's the normal, normalize in a vector, give it a length of 1, and another one that we're going to need, especially when we look at shaders, is the normal vector. And the normal vector is the one that points straight out from a surface. When you go to the reading assignment for module 2, you'll notice that it's just some subsections. The very next one talks about the normal vector. So if we had a vector coming in and bouncing off the surface, there's the normal. The normal would be the thing that points straight out from that surface, and it's like it reflects across that line. Important for light, and that's why we use it when we get to shaders. We have a flat surface, and then we just we tell the computer to change what the straight out direction is, and it makes it look like the surface is no longer flat. We'll see that later, but that's the normal vector, a normal vector. When we go to code as well, we also have a basis, and that is our local coordinate system. Because every object we put in our game has it. There's the overall game world coordinates, but each object also has its own coordinates, right? We can turn back in 3 dimensions. We can turn in different directions. In 2 dimensions, we can rotate and be facing in different directions. So, like, the character X might be a little bit different than the world X. So for that, we use the term basis, which, yeah, I'm just going to leave it at that. A basis. So think of that as where our local coordinates are pointing, because description of that would get really complicated really quick. It's usually like 3 weeks of a linear algebra class just to introduce the word. All right, one quick little picture I had here. So when we're adding vectors like this, right, that's what gets typed in our code. Say vector 2 with 3, 4 plus a vector 2 object with 4, 2, and we store that in some variable. Think about it like this. So we have our object. Let's grab a black marker so we can show clearly. We just need the intuition from it. So we had our object that already had this force applied, and we're adding to it this much shallower force. I'll draw it almost horizontal. And then in the end, what we get, am I still on the screen? Barely. Is this with that first vector followed by the second vector. So our object is still going to move this way. So when you think about that little simple picture when you're adding the vectors, the numbers just kind of go in whatever they are. We're probably reading them from somewhere else anyway, but think about those arrows applied to your object and what they're going to do. Okay, that went 6 minutes longer than I meant for it to. Probably a good time for a break. Anybody have any questions about that? See it in code. Shortly in examples. 10 minutes sound good for a break? Could really use a sip of coffee. And I didn't make any before class, so after trying coffee was I drink really good coffee. All right, my laptop says 2:21. We'll get back to it at 2:31. See y'all in just a moment.